forward to seeing this.
So we're going to have Gene present. So thank you, Gene, so much. Do you want to say something a little bit about yourself?
Yeah, I'll do that right away. So my name is Gene Gotimer. I work for a company called Gotimer, and we do software development. We do quality. We do pipelines, CD, CI, all sorts of transformations. Do a lot of agile coaching, training. And as Cynthia mentioned, I met her up at TestBash Philadelphia, and I was doing this presentation. A lot of people loved it. Because it's really talking about all the different types of tools and tests you can throw into your pipeline, right? When I'm talking about the pipeline, I'm not talking about any specific process. And when I'm talking about the tools, I'm not talking about specifically necessarily these ones that I'm showing you. Most of these are open source, so they're kind of low-hanging fruit. They're easy to grab and start using them. But the point is that as you build out a way to deliver your software, there's a lot of places to add more tests. There's a lot of places you can add more checks and gain more confidence in your code. So, back here. Yeah, I already mentioned about Coveros. We work in this general area. We're a small company that works with a lot of government clients, a lot of commercial clients. But when I talk about the delivery pipeline, most people immediately assume I'm talking about continuous delivery, and that's not really the case. Continuous delivery is great to be in. It's great to be in an environment where everything's automated and you hit a button and everything flows through and you don't have to worry about getting all these tests run or coordinating deploys or anything like that. But for the purposes of this presentation, what I mean when I say the delivery pipeline is just whatever process you use for delivering your software from the time it's a requirement to the time it goes out to the customer, from the time the developers start checking in the code to the time it's pushed out into production, whatever that is, right? And it might be fully automated, it might be manual, it's probably somewhere in between for most people. But again, the goal is I'm taking software and I'm moving it through, and as I get further and further down the path of delivering software, I'm getting closer and closer to production. And so for us, what we're looking for, the whole point for us of the delivery pipeline is, do we have a viable candidate for production? Is what I'm building something that I expect to show up in front of the customer soon? Right? Does this have no chance? Does this have a good chance? Is this looking great? Am I finding little bits of problems? Am I finding lots of problems? Am I finding so many problems that this one's worth giving up on, right? It's just not worth continuing, right? And that's what the pipeline for me is all about, right? The whole goal is to build confidence that we have a viable candidate for production. So how do we do that? Well, we can't put everything up front and say, let's shift everything left, right? And we can't do the typical waterfall of let's shift everything right. We'll just keep pushing things off until we're sure everything's been spec'd out and then everything's been built out. And then we've run through a formal test process or whatever. So we can't shift everything to the right. We have to do a mix of them. And so our goal is, let's do just enough of each type of testing early in the pipeline to determine that further testing is justified, right? In other words, I've done some quick, simple checks, right? Early on, probably do unit tests, right? See that they're passing. If those are passing, I know it's worth going on to the next set of tests, whether they're functional tests or whatever the next test might be, right? But if I'm doing tests and I'm finding that the unit tests are failing, there's no reason to continue, right? Now, for unit tests, most people see that right away, but it really goes for all the tests you do. And this is what really turns the process that you're following, just the written out process of delivering software, into a true pipeline. You're going to go as far as you can until you see that there's a problem, and then you're going to stop with that one because it's not worth continuing. You're going to go back, fix that problem, and push it through again. And you're going to keep stuff moving through the pipeline at all times. All right? So, right, we're trying to say, hey, I have confidence in this, right? I know this is going to work, or I feel this is going to work, right? As opposed to the opposite of, geez, I've got a really bad feeling about this. The last thing you want is to work through a whole development cycle, get to the end, and someone says, okay, is it ready to go to production? You say, maybe, I hope so, right? If you're expecting problems to happen at the end, that's low confidence, right? Naturally. So you want to do some testing up front to find out that you think stuff's going to pass, right? So the whole goal here is to balance early, rapid feedback with no late surprises. Early on, I want to start doing as much as I can, shift left, right? Do a little bit of each type of testing, and then build on that confidence to say, you know what, I invested 10 minutes, it looks good. Let me invest 20 more. Let me invest 30 more. Let me invest a day of manual testing. Let me invest a weekend of soap testing, or whatever the case may be for your product, right? But you're going to have to balance. Can I do some testing up front to say it's worthwhile continuing versus I don't want to do everything up front, and I want to save the expensive stuff for last. So I don't want to be surprised at the end. I want to go into the end saying this is ready for production, and okay, maybe we have one more step to go, but I'm pretty confident it's going to pass. We've never had problems at that point before because we've done some of that testing already. Let's talk about some of the types of tests you can throw at it, right? First, just starting at the beginning, let's start with your code. Check your code footprint, right? If you're using a dependency management system like Apache Maven or something like that, see if you can cut down the number of dependencies you're using, right? A lot of systems today are built on top of framework after framework after framework. And if does anybody here use Maven? You, right? The first time you build with Maven, it downloads the internet, right? And then starts your build. All those dependencies are things you're including into your packaging, including into your system, stuff that you're now responsible for when you deliver to your customer, right? So what you want to do is make your code footprint as small as possible. Cut down those dependencies. Let's get rid of as many as we can. And there's tools with just about every dependency management system. There's tools built into your IDEs to make sure that you're not including any more than you have to. For Apache Maven, it's dependency analyze is really the strongest one, but there's also a couple other plugins that will help you look to see these are things that you've included, but they're not really needed. All right. Once you've done that, start doing some checks to see if your libraries that you are including, that you do have to depend on, that they're up to date. Right. One of the OWASP top 10 is using components with known vulnerabilities. Right, it's been on there for the last 2 versions. And OWASP Dependency Check is a great freeware, great open source project that will take a look at your Maven or at your NuGet or your Node NPM stuff, look through it all, build up basically a bill of materials, see what libraries are being included, and it's just going to take a look through all the databases it can find on the CVEs that are out there, common vulnerability integrations, right? Does this have any vulnerabilities that have already been announced? Okay, I forget exactly what the number was, and I don't think I have it here in my notes. Oh, there we go. In 2016, 5.5% of Java downloads had known vulnerabilities at the time of download. So every time somebody downloaded 20 libraries, one of those was already known to have security problems, right? In 2017, that number went up according to Sonatype. Right? Sonatype's the group that takes care of the Maven Central. So they have a good place to watch all of that happening. Okay? So dependency check, great tool, works with a bunch of different types of software. There's another project just coming out of beta sometime in this quarter called Dependency Track that works with dependency check. Dependency check is something you run once and it'll spit out a report for you. Dependency Track is really built to be built into a continuous integration pipeline, a continuous integration process. Right? That's their goal. It consumes the output of dependency check and can do constant monitoring, not just watching when you're doing builds. All right. Next, look at the quality of your code. Poor quality code is harder to maintain and harder to secure. Okay. If you write clean code, if you spend time, like you said, cleaning up your technical debt, you have a lot less things to worry about, right? Far fewer problems that are going to creep in, problems due to people misinterpreting what you're working with, not realizing what the side effects of the program are, all that type of stuff. There are plenty of static analysis tools out there to help you look at your code, right? They're out there for PHP, they're out there for Python, they're out there for Java, Ruby, just about any language you use, right? And they're very easy to set up and run, and typically they run very quick. So these are things that are easy to run early in the development cycle, right? Because we want to get that early rapid feedback. The other thing about these is they tend to be developer-centric, right? They're good things to throw up there and check, did the developer follow best practices? Are they following our code style guidelines? Are they writing code with simple security bugs in it that we could find, right? For instance, SQL injection is still one of the #1 ways into most hack systems, most hacked online systems, and it's easy to catch most types of SQL injection through static analysis, right? Just looking at someone just appending non-scrubbed strings together rather than using database tools to build up their queries, right? Race conditions, notoriously hard to decipher when you're working with dynamic analysis, right? Because you have to try to hit something at the same time on 2 different systems to get that race condition to happen. Turns out that by using static analysis, a lot of types of race condition can be found right away. So great tools out there, find a lot of different types of problems, bugs, security bugs, code problems, plus things like duplicate code, right? Again, try to reduce your code footprint. If you're duplicating code all over the place, maybe consolidate, parameterize some methods, make them reusable in multiple places, and cut down the amount of code you're maintaining. How many people here use no static analysis on their systems at all? How many people here use SonarQube? Almost no one. SonarQube is considers itself a quality dashboard. It handles running all of these and a lot more different static analysis tools against your code base, and shows you some pretty graphs and great trends, and can break the build if you reaching thresholds like your code coverage is too low, you have too many findings of a particular type or particular severity. If code is getting less clean rather than more clean, great tool. If you haven't played with static analysis, we put SonarQube into every single project we use. It's one of the first things we install. All right. Unit testing. Now, hopefully unit testing is not one of the types of tests that your pipeline is missing. But just a reminder, unit tests are anyway, right? It's not a type of testing to see how the program is, or to see how the system's running. It's checking the code. Does the code do what the developers intended the code to do? Now, hopefully that's what the code's supposed to do, but there's no guarantee of that, right? What we're trying to do is, here's the documentation for what I thought these methods should do, right? Here's how they're supposed to work together, right? You're writing an example of it, and it's runnable and provable that it still works. Okay, enables you to do a lot, including fearless refactoring, which is really, really valuable when you're trying to clean up code. But most people are looking for some way of measuring how good are their unit tests, right? And a lot of people will go to code coverage tools. Okay, how much of my code is executed every time I run the unit test? And that's a great number to start with, except that it doesn't really tell people what they really want to know, which is generally how much of my code is tested. Okay? So, and I mentioned this in Philly, and it stands for today. If you come away with one new type of testing that you hadn't played with before, and you're interested in when you leave here, and it's mutation testing, I would consider this a huge win for me, right? Mutation testing is a way to run your tests, your unit tests, and find out, does it really test any code in my system? Okay? All it does is takes a copy of your source code, and as long as all your tests are passing, it'll modify a copy in memory, just as it's playing around. It'll modify a copy of your source code and see, and change something, change the meaning of an if, reverse it from an if true to an if false, change a string from a value to a null, right? Change an increment to a decrement, something like that. And it just reruns your test again. If your tests all still pass, then whatever change it made, that mutation that it made, is not tested, right? It was something you weren't looking for. So that's code that's not tested, right? So here's some examples. Let's say you had a really simple method, right? It's just incrementing a counter by 1 and returning it, right? If I run mutation testing, maybe it just changes to a decrement, and it reruns the tests. If your tests fail, as they should, because it didn't behave the way it was supposed to, then it says, great, mutation was killed, and it goes on to the next mutation. However, if the mutation survives, then that means we had no test that actually covered that line of code, even though our code coverage tool may say we executed that while we were running our tests. Right? Here's another example. Say we have a string. One of the first things we do in this method that takes the string is check to see if it's null. Right? If it just goes in and mutates it to say if it's not null and the test still pass, well, your tests weren't very good, right? They weren't covering that case. So mutation testing is a really cool way to get the feeling, how good are your tests? Am I actually testing the code the way I thought I did? Okay. It is slower than running unit tests, so it is something you want after that because it's running the unit tests over and over and over each time. Okay. Now it's pretty good. Most of the tools are pretty good about not running every unit test every time it makes every single mutation. It has some optimizations to say this one can affect this one can affect it, but it does check. It does require a lot more time. Not hours and hours more time. If you run unit tests in 2-3 minutes, you're talking 5, 6, 8 minutes, somewhere in there, right, to get these mutations running. And you can turn on and off what's running. So it is something that happens fairly far left, not all the way left. But it's a great way to actually check, do I have a great baseline of unit tests that are actually testing my code before I continue on? All right. Another type of testing, functional testing, right? Again, most people have functional tests. How many people here use something like Selenium, right? A lot of people out there, right? So great tool, right? Does a lot of different types of testing for you functionally, right? And you're not going to run it until after you're sure the code compiles, the unit tests are there, all that, right? But there's other things it can do other than just running, hey, when I push this button, does the right thing happen? Okay? One of the things you can do is something called user role testing, right? Test what users can do or what they can't do, or at least what they shouldn't be able to do. For instance, you have an admin section to a website, right? Maybe you've done all sorts of Selenium tests to make sure that, you know, if you press the admin button, it brings you to the admin menu. It brings up the admin menu. You press on, you know, administer users or list users or something like that, and you see list. Well, what happens if someone who's not an admin clicks on that, or jumps to that URL, or tries to access that? Or let's say you go into your user profile and you try to access somebody else's user profile that you don't have access to. What do they see, right? That's user role testing. Check your role and see, can I not do the things I'm not supposed to? What's the behavior then? Do I just get a 500 error? Do I actually get a nice page? Does it explain what the problem is? Should it be explaining what the problem is, or is that giving away too much information? Right? It all depends how you want it to behave. We use this user role testing with Selenium on a project for the DoD that worked out fantastic for us. Every time we came up with a new feature, we would write 2 sets, generally 2 sets, sometimes maybe 3 or 4, of Selenium tests. The test that should pass for these users, and the test should fail for these users, right? Or not that they fail, but that these users should not be able to access it, right? An admin goes in this bucket, a regular user goes in this bucket. A logged in user goes in this bucket, a non-logged in user goes in this bucket, right? It did a couple things for us. One, it gave us a great feeling anytime we added a feature or changed the way something behaved to see, is there any cascading effect? Did we, by virtue of some change we made, did we accidentally give people access to the admin or to somebody else's account or something like that? The other thing it did is we did this while we were doing our development. So as soon as we came up with the story to add the new feature, we say, okay, so what should happen? Okay, if I'm not that type of user, what happens then? What's the behavior there? And we built out this matrix automatically as we were going through our development of what should happen for users that can access it and what should happen for users that can't. Right? It ended up being a great time saver for us down the road as we added new features. So user role testing, great way to do things. Another way of reusing your functional tests is by passing them through a proxy. Right? How many people here have used Fiddler? Right? That's one of the most popular proxies that people use in web development. There's other proxies out there that focus on security. One of them by OWASP is called OWASP-ZAP, the Z Attack Proxy. And all it does is as you pass traffic through it, it just looks at the traffic going back and forth and looks for evidence of cross-site scripting, cross-site request forgeries, SQL injection, things that are being pulled down from non-secure sites, even when you're hitting a secured site, that type of thing, right? It can work completely passively. It does have an active mode, and you can teach it how to do better things. But for the purposes of this, one of the things we do at this point when we're running our functional test, we're just running our Selenium suite through. We just set it up with OWASP Zap as a proxy. And just while our normal regression tests, functional tests are running, we're doing security testing as well. We're getting back a report at the end that says, hey, while you did all that testing, we saw these cross-site scripting vulnerabilities that could be exploited. So go ahead and fix them. All right. It works whether you're doing, It works whether you're doing automated tests. It actually even works if you're doing manual testing, right? You just have your manual testers set it up just like they set up Fiddler, and just as they're surfing, it slows it down a slight bit, milliseconds on each request, but nothing really noticeable. And you start getting back security findings right away. Easy to see. They're highlighted red, yellow, green. Okay, nice and easy to interpret. And a plug for Coveros, we just took over the maintenance of a plugin called the Zap Sonar plugin. It's just will consume the output of Zap into Sonar Cube, so you can display the findings in there, show your security findings along with your other quality dashboard stuff. All right, some other things worth looking at. Test the APIs that you depend on. More and more of us are using more and more services on every call, right? It's not just your website you're dealing with, but you're dealing with third parties that you're hitting behind the scenes, whether it's just Google Analytics or a third-party vendor that you're reaching out to, or internal services that you have to hit on the inside. Whenever you're dependent on an API, test those APIs. See not only what happens when it works the way it's supposed to and the way you expect it, what happens when you give it bad input? What happens when it goes down? What are the kinds of things that happen in the non-sunny day scenarios, right? Get used to those early on. Using tools like SoapUI and Postman to do some proxying, they give a great opportunity to manipulate the results in and out, so that you can create situations that you normally might have trouble trying to programmatically create. Seeing what's the behavior supposed to be, with great exploratory tools, right? And once you've kind of got a feel for how those all work, there's all sorts of tools you can use, including Postman, but also WireMock, Hoverfly, Mockable.io. They're great services to go out there and build mock services. So now you can write your tests against these mock services that aren't down, so you don't have to be hitting that third-party vendor. Or early on in the pipeline, you can keep everything local on one box. You don't have to worry about the network going down. You don't have to worry about putting this out on someplace that can get out to the internet, depending on how your network's configured, right? You set mocks. Now, you still at some point want to test with the real service to make sure that it's still behaving the way it was supposed to. But these tools just really let you do a proxy once, and they say, okay, anytime I get that result back, I'm going to give you a result that looks like this. And you can modify them programmatically. You can have it generate like new IDs each time, or just behave like really behave like the real service would, without having to hit that real service. Another thing that a lot of people don't think of as testing is analytics. What are your users doing? Okay, hook up in your systems PWIP if you don't want to send your stuff out of your control, or Google Analytics, which is by far the big winner in analytics graphing and displays. Those will just tell you a lot about what your user's doing. You can start getting a feel for, hey, where do my users spend all their time? What functions are they using most often? Which ones do they have to go back to over and over and over, right? And maybe there's some places we can improve the UI or improve the experience, right? Also, spend some time looking at your logs, right? Splunk is the big commercial log analyzer, but there's also an Elk Stack, Elasticsearch, Logstash, Kibana. Right, and there's all sorts of services and products in between that you can use. But those are kind of the two big ones. There's Splunk, which lets you throw tons of stuff at it, collects logs from every type of system you have, every type of log you want to throw at it, collects them, gives you a Google-like interface to search them, and find out what your user is doing, set alerts, set notifications based on errors happening or whatever you want, down to but you're sending all that out or paying for that based on how much volume you create, or you set it up yourself with the Elk stack. How many people here use Elk? Couple? All right. How do you like it?
It's good to use it for some internal CI stats.
Do you wish you paid for Splunk?
I'll leave the answer to someone else. No, I think I like it.
Most of the projects I've worked on use Splunk and end up costing a lot more than they expected, but they immediately become dependent on it and couldn't even bear to think of getting rid of it. So, all right. Another thing to do is automate your deploys. Now, I said you didn't have to have automation in order to make a pipeline, which you don't, but there are a lot of advantages to having automated deploys that will enable a lot of types of testing to happen. Right? Most people think, oh, if I automate the deploy, I speed up the pipeline, which is true frequently, but the big thing it allows you to do is more tests. It gives you the opportunity to set up systems whenever you want, as often as you want, to tear them down quickly, build them back up, and do it repeatably and reliably. And that's the huge win. Every time I run this, I'm going to stand up a system and it's going to look just like the system I stood up before it with the new changes. I don't have to worry that someone forgot to set a configuration setting. I don't have to worry about, oh, I forgot to put that in place, or I started up the servers in the wrong order, or anything like that. If I'm using tools like Chef, Ansible, Puppet, right, or if I'm building images with Packer, or if I'm just doing everything containerized with Docker, right, all of those let me stand up a system, configure it programmatically, and have it stand up in my pipeline as often as I want, repeatedly, reliably, every time. Okay, so you want to test out a new version? Boom, you stand up a new system for it, right? Someone says, hey, can you show me a demo of the features that are still in flight, even though they're not ready for production? Yep, just stand up a new system because we can run this. You want to run a 3-day soak test, but you don't have an environment for it? Well, we'll stand up a new one. Start it running off the side. It's not holding anybody up. Nobody else was relying on that system. We'll do the soak test and check back on it when it's all done, right? A lot of different advantages you have when you have automation to do your builds. You want to test every deployment, especially if you're doing automated deployments, right? Smoke testing. Make sure that your deploy worked, right? And that's really what the key of smoke tests are. We're not testing that the application does what it's supposed to. We're testing that the deployment worked and everything stood up the way it was supposed to. So in other words, let's look at the interfaces. Let's look at the username password for the database, making sure we can get to the database. Do we have the network configured correctly? Right? Did something go wrong during the deploy? Because if something went wrong during the deploy, it's not worth it for us to go ahead and kick off a whole set of tests that are going to run all weekend, only to find out, hey, we forgot to set that one configuration value, right? So this happened to be posted in Twitter, I think last week. I happened to see it. This is smoke test in the wild, right? This is what it's doing. It's just doing one quick check to see, hey, if you hit that sign, you know to stop long before it becomes a problem. We've invested a lot of effort into trying to unstick you from under the bridge, right? Again, focus on the basic signs of life. Is the system up and running? The interfaces between the systems. Generally, in a simple app, that's going to be, can we get to our database? Can we get to our login system? That type of thing. And anywhere where you have a configuration that changes on a per system basis. Next, we talked about checking to make sure we weren't using components with known vulnerabilities early on, right, in the development. But there's also all the systems we use. Once we're standing up these full systems and deploying to these systems, we want to see that all the other pieces of software that we depend on, that they don't have vulnerabilities. Are they all up to date? Are we using the latest and greatest? Not the ones that have known vulnerabilities, not ones that have known slow performance or have problems with them that are going to hurt us some other way. So keep things up to date. Use whatever your package control system is, whether it's Windows Server Update Services, if you're using Ubuntu, apt-get, you're using Red Hat based Linux, it's usually some version of Yum or RPM. Keep those things up to date, run them frequently. And that is every time you do a new deploy and you have the upgraded pieces in place, you immediately find out, hey, a new version of SSH came out, and that's going to break our system because we need a new configuration value, or we just added this new library, and there's some slight incompatibility. We need to upgrade something else in our system, right? Do it as part of your normal process, and that way you're always doing it incrementally. You can react to it proactively rather than, hey, we just had to apply these patches in production and everything just broke. I suggest everybody that deals with any type of system subscribe to the US CERT weekly vulnerability summary. It's a list of all the announced CVEs that were sent out in the prior week. It's just a big long list. You can read through it, scan through to see are any of the packages that they're talking about stuff I use on my systems. Right? If you really want to be cutting edge, there's a mailing list called Full Disclosure. That's where people talk about every bug they find as they find them. So it's kind of, if you want to be cutting edge, you deal with it there. If you just want to know, hey, do I have upgrades to make on my systems this week? US CERT is weekly vulnerability summary is a great package to look through. It comes out. It used to come out on Monday mornings. Now it's Monday afternoon to Tuesday morning sometimes. But you get a package or a email that you can just scan through in about 10, 15 minutes and just see, hey, do any of these concern me? When you're putting up your dev and test systems, especially when you start using the automation, you start realizing you have a proliferation of systems, right? A lot of boxes get out there. You start putting them out on the system, and you start realizing, you know what? There's no such thing in the cloud as just a dev system, just a test system, right? Every system is open to being hacked, right? So one of the things you want to do is start protecting them. Now, the nice thing about this is you get used to having all those protections in place, so that when you go to put the same types of protections in production, you know your systems will work with them. There's a lot of great free tools out there, and although most people have some sort of compliance rules and some sort of operations guide that says, in production, we will use these tools, and maybe they're too expensive or too cumbersome to use in your test and dev environments, there are free versions of a lot of them out there. Fail to ban is just a brute force protection system. It just watches logs, and if someone tries to log in from the same IP address and gets the wrong username and password combination 3 times in 5 minutes, it just puts up an IP tables, blocks them at the firewall, right? Or if they do it 10 times over the course of 2 hours or something like that, right? You can configure it, and it comes with a lot of rules and stuff to do that. But all it's doing is trying to prevent or slow down brute force attacks against your systems. AID is very much like Tripwire. It's an intrusion detection system, really an integrity checker. It just, you tell it what directories you want to look at, and it just takes a snapshot of the SHA-1s and checksums of all those files. If any of them change, it sends you an email, right? So if someone does get onto your system and makes a change, or more frequently, some well-meaning but misguided operations individual goes in to help you with your system that's otherwise programmatically configured, and they decide to make some changes to help you out, you find out about it right away, which actually has been our experience that we find much more often someone just goes onto the box and makes a change. They forget that we do all our changes through Puppet or all our changes through Chef. Last one on there that I have here, OpenSCAP. How many people have to deal with STIGs? Anybody know what the STIGs are? Well, just a couple. So the STIGs are a list of, which stands for Secure Technical Implementation Guidelines. It's really just a series of best practices. It's put out by NIST. It's also put out by the DoD. DISA has its own set, and other environments have their own things they call, I think, Health and Human Services, someone told me the other day, calls them ASRs. It's the same thing, just a list of best practices. If you have SSH turned on your system, then you shall lock it down this way, right? Don't allow root logins. Don't allow people to access anything without a password. Make sure you have these policies in place for rotating passwords on the system. If you have a web server, Make sure you have it locked down this way. Make sure you can't write to the configuration directories, all stuff like that. So all good ideas, even if it's not required of you on compliance. And OpenSCAP is just a great way to run through a lot of the automatable pieces of that checklist to say, hey, am I following best practices? One of the things we found really useful to do with it is to run it on any system we're standing up on the baseline before we do any installs. So we have a golden image for Red Hat. We stand up our Red Hat, and before we install anything on it, we run a quick OpenSCAP on it, right? Make sure we haven't started with a known broken system or a known vulnerable system. Then we install our stuff and check again. That way we know that, hey, if there's any problems with this, we just introduced it with that deploy, right? It's a really easy way to check. And one thing to keep in mind, don't forget your infrastructure. People do this on their systems that they're deploying to, but they forget they have a CI system, they have GitHub or GitLab or database service that they're running, or their SSO login system. Anything you use, put these controls on them and make sure you're protected, especially if you're in the cloud. Yeah, question?
Well, I was just going to make a comment. Over the years, I've done a lot of work with DoD and the government agencies, and STIGs really cause a problem when they're taken to the nth degree, because I'll just pick on the Army. We went to install an application on a server for the Army in a STIG environment in a classified data center, and of course it wouldn't install because it had to do things to the environment while it was installed. So then it took an act of Congress and basically, a lot of hard work to get them to relax the STIGs temporarily so that the product could be installed and then reapply the STIG.
Yeah, and one of the great things about using automation, automated tools to do deploys and tools like OpenSCAP is we can show, hey, look, we're starting with your golden image. It has these problems based on the latest STIG guidelines. So these problems that you see here, they're the ones that you told us to start with. So we're going to get better from there, and we're going to install our software, and you can see it's all closed back up. And even though we opened up a whole bunch of permissions so we could do the install, we close them back down at the end, and here's our report. There's some efforts out of MITRE right now to do some work to take the things that are put in through OpenSCAP, all the changes, and map them to specific controls, the ID numbers that you get out of the STIG and other systems, so that you can run it through and get a report and say, hey, not only do I see green on all of these when I do all these checks, but that means that I've answered each of these has addressed these particular controls, to make it really easy for an auditor to go in and say, did you address this control? We can just search that and say, yes, it was done because we ran this rule.
So would that OpenSCAP help you to achieve a ATO?
Yeah. Yes, and that's the first time we started using it was specifically for that. Right? We're using Puppet to run it. We'd run OpenSCAP. Anything it found, we'd write a Puppet manifest that would close down whatever vulnerability it is or whatever finding it was, and that would just become a normal part of our deploy. Another tool that I haven't played much with, but it's getting more popular, is called Inspec. Inspec is by Chef. It's open source, but Chef is really stewards of it. And it's a simple language, very Chef-like, very Ruby-like, that lets you check how your system's doing so that you can write compliance rules. Some of the things Chef lets you specify, I want to make sure I have OpenSSH installed, and I want to make sure it's listening on port 22, right? Inspec can check this, not listening on any other ports, that any other ports are closed, that not just did I put the firewall rules in place, but it can actually check, did it take effect, right? Are those ports actually closed? Things like that. They have whole suites of systems, including all the STIGs, already written up as Inspec rules, and they're supposedly very, very easy to implement. We've used this on some projects. I personally haven't played with it, but it's a great way to codify your compliance early. Right? I think their actual tagline is compliance is code. So you codify it and run this to generate your report to say, hey, look, we are meeting all the compliance controls we're supposed to. One thing that people forget sometimes is testing the database, right? You think about testing this code you wrote, but there's a lot of other pieces, other things you can check. SQL map. Great tool for going through your web front end to try to see if it can exploit any SQL injection problems or enumeration problems, where I can get like a list of all the users or a list of all the table names through the front end, right? It's automated, very easy to use and set up. DB unit is just a way of putting data into a database so you can run, they call them unit tests. In fact, if you're using a database means they're definitively not unit tests, but early developer tests, right? Against the database, put data in and compare it to the results in a way that the database understands, right? You can set it up as XML. You don't have to worry about schemas because it's more flexible than that just by using XML. So if you add a new column, it doesn't automatically break all your tests that were depending on that data, things like that. PG Badger is a tool we played around with and had a lot of great success with. It's just an analytics tool. All it does is look at, in this case, Postgres logs. Percona has a product that will look at MySQL logs, and just about every database out there has something that will analyze the logs and tell you what's the most popular query, right? What's the one that runs most often, right? How much of your time is spent doing that? We tied that to tests we wrote in Apache JMeter, hit the database. So anytime we change the configuration of our database, specifically when we were doing some STIG work on it to change the auditing, didn't slow it down, right? Did we add so much logging that we've actually made our database so slow that it won't perform the way we want it to, right? It's very easy to set up based on, hey, 80% of all our queries were this one select. The next 10% of our queries were this one write. So let's go ahead and write a JMeter suite that will let me do performance testing directly against the JDBC layer in our case, and get back some results and say, hey, things are running this fast. Didn't matter what numbers we got back. What mattered was we had a baseline and we said, hey, as long as we keep that going this fast or faster, we're good. If we add anything and all of a sudden this jumps by 5% or 10%, we say, okay, some change we just made slowed the database down. We need to go look at it, right? And the reason we actually implemented that was we were, like I said, putting STIGs into place, adding auditing. And the first time we ran the auditing changes, we said, you know, that looks like it's running a lot slower than it used to. We backed them all out temporarily, did a quick check, set a baseline, put them in. Sure enough, we were slowing things down by about 30%. We went ahead and made some tweaks, changed it, made sure we were doing everything as doing what we needed to do to meet compliance, but not doing too much more, and had it all configured right so we were making our performance numbers. All right, speaking of, how's performance overall, right? There's all sorts of different types of performance you can look at when you're building your systems, okay? I just talked JMeter, right, for doing your database, but you could also obviously use JMeter to check just how your web page is responding. Can I do some stress testing, some load testing on it, right? You can use a tool like Gatling. A lot of people have really liked Gatling recently. I played with it many, many years ago and really liked it, but our client wanted us to use JMeter, so I never got a chance to play with it. But recently, almost every team in Coveros has picked up Gatling instead, so we really, really like it. You can just look at MRTG. It was an old school way of looking at network reports. Or am I generating a lot of network traffic? Easy to set up. But the other one that people overlook a lot is build times. How long is your build taking? Right? Just look right in Jenkins. Right in your CI engine. How long does it take to run all my unit tests? Is that slowing down significantly? Because if your unit tests all of a sudden start going a lot slower and you didn't just add a lot of new unit tests, well then maybe you did slow something down. Maybe something you just added is making the system run slower. It's a great way to check the health of your build system. The other thing that's worth looking at is how many people here do continuous integration? Right? How long is your first developer cycle, right? From the time check-in to the time they get a green light on CI, do you guys know? 2 hours? So for true CI, which admittedly doesn't happen in a lot of places, for true CI, what you'd want to have happen is the developer checks in code, sits there and waits until the code passes the compile, passes the unit test and whatever early tests, and then they get the green light that says, what you just did was good, and now they can get up and go get a cup of coffee, right? If it's 2 hours, that's a long time to have them sitting there doing nothing. So what are they going to do? Well, they're going to wander off and go do something else. They're going to start another task. They're going to start programming somewhere else. And then if they find out that something failed in that build, they have to undo or push off to the side what they were now working on and go back and get context switched back. They've gone off to lunch. You need to catch them as soon as they get back in, say, hey, you broke the build. Can you come back and fix it? That type of thing. So True CI says you should put a limit on it, 10 minutes, right? No build should take longer than 10 minutes. You start watching this trend, you can start tuning. How many unit tests really need to run before that 10 minutes are up? Can I pick, these are the ones that we're working in this part of the system, so I'm just gonna run these unit tests, and then I'm gonna set my developers free so they can go work on the next thing, or go to the restroom and go grab coffee or whatever it is, right? And I can keep tuning it just by watching. Am I getting close to that 10 minutes? Do I need to start taking some of the tests and putting them after the first CI cycle? I mentioned right in the beginning, right, balancing early rapid feedback with no late surprises. Keep in mind that early checks, when you're doing stuff, they can be really, really lightweight. You don't need to be full-blown, all-inclusive tests, right? If I want to do some security testing early on, or if I want to do security testing as part of my pipeline, I can do some early tests early on, right? Let's say I want to do a full, load and performance. I want to do a full load and performance test at the end. I'm going to use dedicated environments, so there's no other traffic, nothing else skewing my results. I want to get real numbers. How much can we support, right? The production side servers, I'm going to throw 1,000 concurrent users at it for 4 hours, and I'm going to get some feedback. What's my sustained capacity and throughput for those 4 hours, right? Something you might need to know before you go to production. Well, if you have to do this on every build, you've added 4 hours to every build. You're tying up an environment for it. You have to have production size servers, right? It's just never going to fly. But you don't want to wait till the end when we have time to do that full-blown load and performance test to get back load numbers, right? So maybe we just run a short JMeter test, right? On the developer system, on the test system, whatever, no isolation. So there's other traffic. It might be more variable numbers than you're used to getting in a true load and performance test. But we can get some ballpark figures, right? We can see, hey, what's the trend? Are we getting slower or faster? Just like I was talking about some of the testing we've done before, right? And if you're getting significantly slower, I can kill the pipeline right then and look into it, fix the problem before we start investing all the time to do a full load and performance test. And for security testing, let's say at the end of your pipeline, you have requirements that your security team is going to go ahead, or your corporate security group is going to go ahead and do HP web inspect, right? They're going to run, see if you have any cross-site scripting vulnerabilities. And then they're going to run Nessus on all your systems, or Retina on all your systems, and decide, hey, do you have open ports? Do you have CVEs that are known out there? Is the system compliant with all our requirements, right? Those are expensive. They need training to use them. It's hard to get time on those systems sometimes, but maybe you can do something similar and answer the same questions with open source software that runs quicker in the early on. Like I said, we can piggyback on our regression tests or our functional tests using OWASP and get some of the same results. I can run OpenVAS, which is actually an open source fork of Nessus, and just see, hey, do I get that same information? And all this is going to do is early on, I can do these tests before I turn them over for the official test that someone's going to bless the system and says you're compliant, you can go forth. Right? I'm building confidence that what I have is a viable candidate for production. Right? And I can do that by using some lighter weight tests earlier on in the system before I turn it over for the official tests. One of the biggest mistakes we made on a couple of our early DevOps projects was not stepping on people's toes. We didn't want to bother the corporate security group, or in our case, the DoD security group that was handling our stuff, right? If we start doing security scanning, we could never get permission to get the right tools. It wouldn't be the same thing. They'd never let us take over for them. And we realized later than we should have that it didn't matter. It didn't matter if this replaces it. All we want to do is run some early tests so that when we hand it over to them, we're confident we're not going to run into any problems. We're not going to get that late surprise, right? If they find something that truly is a surprise to us, and so we know, hey, we were confident we had it, but we missed one test, okay? Let's put it back in our system and let's add that test. And next time it goes through, we won't get caught again. All of those types of things go for all the non-functional tests, right? There's obviously a ton of different types of non-functional tests. And of all the types of testing, one of the most overlooked often when you're trying to trying to plan out a test plan is the non-functional stuff, right? Some of this can be automated, some of it can't. Some of it can be partially automated, some of it can't. It's worth keeping a list like this around. This list is up. I'm sure I can send it out if you guys want it. To keep this list around, and periodically when you go back, say, hey, you know, pipeline's running really well. Is there any other type of test we can go in? Read through some list of non-functional tests and say, hey, you know what? We probably should do some resiliency testing. We probably should do some endurance testing, some ergonomics, some whatever, right? Speaking of resiliency, plan for failure. How many people here know what the chaos monkey is? Not enough. Chaos monkey is one of my favorite DevOps stories of all time, right? Netflix has this open source tool. Now it's called the Simian Army, but at the time, the first tool was really called Chaos Monkey. And what it does is it goes into their AWS scaling groups and randomly takes out systems during the day, Monday through Friday, 8 to 5, while people are in the office, in production. It kills systems that are running. Why? Because if things only go bad every once in a while, then the operations group will not know how to deal with it. Instead, on any given day, 3, 4, 5 times a day, they deal with the system going down. They know their system handles it automatically. They get the alerts, they pop their heads up, take a look, everything's working good, they go right back to what they were doing. It's a non-issue for them. They always know that no matter how bad one box is getting or a couple boxes are getting, that Netflix will stay up. If you have spent any time using Netflix, you have been hit by Chaos Monkey, right? The numbers are just completely in their favor that you've had the system go out from underneath you, and you probably never even noticed. What I want to know is the engineer who walked up to their boss and said, hey, boss, I've got this great idea. You know how we're trying to deal with problems in production?
Let's cause them.
Let's cause them. Let's make them happen all the time and get used to it. Right? They have some other tools out there that take out they'll simulate taking out whole AWS zones. They'll do security scanning, all sorts of things, all around the idea of resiliency, right? Causing problems early and plan for disaster. You know things are going to go wrong, so you may as well have some plan. If the first time you have to deal with it, trying to bring a system back to life, is with managers yelling at you and customers crying in your ear, or vice versa, you're going to have trouble doing it, right? But if you're used to doing it, if it's something you know the system can handle, you have the tools you need to troubleshoot and get things working again, there's no panic, it's just situation normal, and you can get things back up and running. Last, test your pipeline, right? The pipeline that you build out, your CI engine, your Git, your Subversion, whatever you're using, all those tools that you use to build out the pipeline, as you get more and more automation in there, become more and more a part of your critical, right? It's no longer the Jenkins system that somebody set up on their desk and happened to start doing your builds so that nobody had to run Maven over and over. Right now, this is something that every developer, every tester, every operations person depends on. You can't afford for it to go down. So test your pipeline. Make sure it's engineered just like any other production system, because even though it's internal and you're the consumer, it quickly becomes critical infrastructure and becomes your production systems. You need to make sure that you can keep stuff flowing through your pipeline if things go wrong. You need to have backup strategies. You need to know what happens when you reach capacity on your Jenkins or on your Git, whatever it is. Right? You don't want everything running to a halt just because you haven't planned that out. All right. So one of the things our social media director at Coveros has us do every time we write a blog or do a presentation or something is come up with 5 takeaways, or 5 key takeaways. He calls it the Coveros 5. So my Coveros 5 for this, right? First of all, remember that the pipeline is about building confidence that you have a viable candidate for production, right? So when you're building out your test plans, when you're adding your tests, do it with that in mind. Is adding this test going to give me confidence that I have a viable candidate for production? And vice versa, if I'm not confident that this is ready for production, what's missing? What type of test did I leave out? Can I add Do just enough of each type of testing early in the pipeline to determine if further testing is justified, right? You want to balance the early rapid feedback with no late surprises. Like I said, my pet project is to spread the word about mutation testing. Use mutation testing, make sure your unit tests are actually covering what you need covered, right? Mutation testing is going to tell you what most people think code coverage really tells you, which is how much of my code is tested, right? Some testing is better than no testing, okay? Even just watching trends or doing a little bit of some testing might give you enough confidence that you can move forward. Don't worry about not being able to do a full-blown soak test or a full-blown security scan or really have to do something in depth. You can do a little bit, they'll give you a little bit of confidence. That might be enough, right? And watching trends is a great way to do some of that. I don't need to know the exact numbers for my performance, but maybe just knowing, hey, things are getting a little bit faster, so I'm good. As long as they're not getting slower, I know I can continue on this path. And the fifth, never expect that your pipeline's done, right? A little better is still better. Keep improving. Always go through the trouble of looking at it. Hey, what do I need to add more confidence here? What do I need to feel better about my pipeline? What can we do to improve things, to make them faster, more resilient, easier to use, right? What are we missing? And that's it.
Thank you, Gene.
Any questions?
Speaking of pushing these to the left, pre-commit hooks, what are your feelings on that? I know they can be a little bit controversial with some developers.
So I love pre-commit hooks. A pre-commit hook is when you check something in before the commit actually takes place. It will run a series of checks, right? It can be very simple to make sure, hey, I'm not checking in any binaries or something like that. It can be just virus checking, but really good pre-commit hooks are often on, let's say it's Java code, we'll run the Maven build and then run the unit tests and maybe even some stack analysis and make sure you pass full your minimum threshold before it even gets into commit. So it's really, really difficult for any one developer to break the build because it never gets into the build until they pass those pre-commit hooks. I love them. I think it's great. It really saves you a lot of trouble because even though developers should be running those things on their own machine before they check in, just make sure they actually do. And to make sure they didn't miss something, there a file they left out or configuration value that they had set in a global setting on their box. They didn't remember the need to go onto the development, onto the system to be deployed. Anybody here ever use TeamCity for a CI box? One of the great features of TeamCity, it's by IntelliJ rather. They have some free offering, and I forget what the limits are on it now, but it builds in pre-commit builds. And so anytime you set up a CI job, when you commit, all you do is hit a checkbox on the configuration, and before any commit takes place, it sets up the pre-commit build to do exactly the same build that CI build would have done. So it's not just do these checks, it's actually, hey, when I get to the end of this build, would it have passed? And it just really keeps your pipeline much, much cleaner because bad things just don't get in there. The downside is you pay twice for every commit, right? The build you run, the static analysis you run, the unit test you run are going to run twice because they're going to run once pre-commit, then it's going to commit and it's going to run them again, which is another reason to watch the trends in your builds to make sure they're fast. If you can get that down to 2-3 minutes, which is absolutely possible, especially if you're doing small pieces, microservices, anything like that, it's very easy to get those builds down there. 2-3 minutes versus 5-6 minutes, nobody really notices that very much, and you're safer. Anyone else?
For mutation testing, can the system tell when it changes the test if the given input to the function based on the input to the function, should the results have been different?
So it depends on the tool. There's mutation testing tools for every different language, as you might imagine, right? For Java, it's PyTest is the one I use. For .NET, there's one called Ninja Turtles because they're code mutating, so it's code mutating Ninja Turtles. They have Mutator or Mutate for Ruby, PyMute for Python. They all work slightly different. They all report slightly differently. But most of them, what they do is they just tell you, hey, this mutation survived. When I change this equal sign to a not equal sign, when I change this greater than sign to a less than or equal to sign. The thing still passed. So
It seems like that can create a lot of noise, because it may be that conditional wasn't part of the flow.
So the good news is, what you can do is write annotations in Java or Java programmers. You have asserts, right, like in most unit testing frameworks, but you also have assumes, which are the same thing, but it just tells you, hey, I'm not even going to start this test if these assumptions aren't met. And you can say, hey, this is never going to be null, so I can assume that it's not null. If it does end up being null for its mutation, you can say, hey, I'm just not running this, and mutation testing can pick up on that and say, okay, that's a non-starter. I don't need to worry about that case. They've handled it elsewhere, then I'm not seeing in the unit tests. Right. There's other types of things you can do to protect against it, including tuning the mutation. But in most cases, it can still tell you how your coverage is. And like code coverage tools, you're not really aiming for 100%. You're not looking for never a failing or a surviving mutation. You're looking to see, did I cover all these things? If you run into cases that just aren't worth protecting against because it's just not going to happen in the system, you can go ahead and just ignore it. What we find is people jump to that pretty quickly, though. We want them to make the case. Is it really never going to happen? 2 copies of the software will never, ever run on the same system. It will never allow it to happen. Right up until the busy season comes, they want to run this as a batch job 8 times on that system, and then all of a sudden they start running into race conditions. We have to say, we told you you have to write a thread save. Oh, but I'm only using 1 thread. Yes, you're using 1 thread 8 times. Right. So we like to close things down as much as possible. At least have some note. Just put a comment in there and say, hey, this can never happen. Here's why. So when it does happen, someone goes in and says, oh, I see, we made an assumption. This was never supposed to happen. We didn't code for it, so it's protected some other way. Anyone else? All right. Well, thank you very much.